Hello everyone, thank you for being here. We're Team 4, and in our A2 group assignment, we had the chance to choose the real estate dataset from Kaggle. In the preview of this dataset, we observed that the real estate dataset uncovered insights and trends on the housing market, as well as we aim to understand the dynamics of the real estate market to have decision making for buyers, sellers, investors, and policymakers. Analyzing the real estate data will help us identify trends and patterns in the housing market, such as price movements, demands and supply fluctuations, and regional differences. When describing the dataset, we noticed that the property sales data was collected from 2007 to 2019 in one given region. It provides insights into the real estate market. Nevertheless, it has houses and units that vary from bedroom counts from 1 to 5. We also noted that the cross-dependent variables and their multi-time series variables. This dataset has more than one time-dependent variable, and each depends not only in its past values, but also it has some dependency on other values. The dataset also provides a comprehensive view of the real estate transactions, including price, location, and property characteristics. After doing the descriptive statistics, we decided to use the Clean Data DF as a smaller and more refined data frame containing cleaned and transformed data. Therefore, we also saw that the distribution of prices is likely skewed to the right, meaning some higher prices are pulling the mean upward. Also, the standard deviation showed significant variation in median prices, indicating that the real estate market represented in this dataset has a wide range of property values. Our first insights into the data visualization came from the correlation matrix, which revealed a substantial positive link between the number of bedrooms and the mean average sale price of a real estate, suggesting that the average sale price of homes with more bedrooms is often higher. We also identified that price and postcode have a slight negative correlation, suggesting a little to no link between the two. Hence, when considering all the correlation analysis, we can see that there's a moderate positive connection between the price and the number of bedrooms, indicating that the residents with more bedrooms often come with higher prices. Then it came the scatter metrics with the real estate data. We saw that the median price of distribution shows that apartments typically have lower prices than homes. This makes sense, given that the houses are typically larger and have more facilities, making them more expensive. Also, the scatter plot shows a positive correlation between the number of bedrooms and the median price, as we said before, with the median prices rising as more bedrooms are added. The homes in green are generally higher median costs than apartments that are in red, especially when the number of bedrooms increases. Also, the distribution of bedroom counts. The scatter plot displays the distribution of bedroom counts for both homes and apartments. Houses offer a greater variety of bedroom counts, reaching up to 5, whereas apartments are more focused around 1 to 3 bedrooms. Once we plotted the distribution of real estate median prices, we saw that there's a concentration of homes with a median cost of about 0.5 million, which is going to be $500,000, and we see that is in between the median and the mean among all the real estate properties. This suggests a well-balanced market with moderate price fluctuations, as the majority of the real estate transactions are in the mid-range price range. Also, when we look at a blocks plot with the distribution of the real estate median prices, it becomes even more clear, as we see that there is a solid line for the $500,000 median price and is close to the mean, and we see that the box represents 50% of the market, and that's going to be the majority of the real estate units and households. Later on, we also looked at a heat map with the median prices over time, and there we see clearly how houses in 2007 have lower prices and then they gradually increase up to 2019. Nevertheless, the units from 2007 to 2019 remain relatively the same, so we can see that the price for houses increase over time from green to blue, and then the units prices remain stable, they're consistently green. As well, when we have the real estate median prices over time, we see that there's a significant volatility due to market instability throughout 2007 to 2008, which most likely had to do with the financial crisis of '08. Nevertheless, from 2018 to 2019, we see price peaking, and then from 2009 onwards, there's a steady upward trend in the market of real estate. That's why we believe that from 2020, there's gonna be stabilization with slight fluctuations. In order to predict those prices and the fluctuations, we came up with a regression model analysis. And once predicting the median property prices using features as bedrooms, property types, and standard price, we reached an R-square of 0.88 almost, and this metric indicates that it explains nearly 88% of the variation in property prices, as well as an average error of $42,000. This amount from the actual prices, we see that we have a good model to predict future prices. When we see on this plot the dots that are close to the line, they mean that the model is close to between the predicted prices to the actual prices. So once we trained our data set based on the data that we had, and then we tested on our model, we were able to find values like this. In order to have a reliable performance with the R-square that we already secured, and then have potential improvements, we aim to incorporate more features, gather more data, handle outliers as we see that the residuals in that instance might be something different. We might have residuals that are especially located in one location, or they might have some sort of different postal code, as well as the different price for either house or unit. So one way to improve our model later on as an insight and propose different strategies would be to evaluate those residuals and understand why they are throwing off the model. As well as further model tuning, we have feature engineering and other things that we'll explore. Nevertheless, we do have a good model to predict the future prices of the real estate market data. Thank you.